Okay. It looks like this is it for now. Uh, Hopefully someone will watch the recording. Um, I feel like I should start with a couple of announcements, although I don't know if it makes sense to make announcements when there's still to hear them. But uh, like I said, hopefully someone will watch the recording. The first thing is apparently something's wrong with the Zoom links for my office hours. Okay.
The Monday one, potentially, even though it wasn't the right one for today, but the Tuesday brought me to like a 404.
Okay. I'll have to figure out what's wrong with that. Um, Hopefully the fact that I'd never heard about this before means that no one was trying to get into that office hour. And the other is someone asked me about the in-person final. I still didn't, I should have looked at the syllabus to see what it actually says, but apparently it doesn't, apparently it's not well described on the syllabus. But I explained what it is at the beginning of the course, right? It's so first of all, it shouldn't take 3 hours. We're scheduled for 3 hours, like 7:30 to 10:30, which is ridiculous. But um, I mean, I haven't written it yet. That's something else I have to do, but it's just going to be like a few questions about the assignments that you already handed in. So like, if you wrote a paper, what was the thesis of the paper? Or, like because you outline your main argument, something like that. And it's experimental. I don't know, like, and if you answered the questions, it'd be like, which questions did you answer? And I don't know. That's I have a little hard time figuring out what that would be, but something like that. And yeah, I don't know whether this will give good information or not. I'm just like hoping that this might be hard to do if like you had AI write your assignment. Um, so, like ideally, well, I would hate this, but anyway, whether I'd like it or not, I don't have time for it. Like ideally, everyone in the class would come in and talk about their paper to me or something like that. But I can't, there's no way of doing that. So, and then I figure like, well, at least if AI did write your assignment, at least you'll have to try to understand what it wrote. You're gonna learn something from that. So, yeah, but like I said, I don't know if it'll work that much, if it'll work that well. That's why it's listed. I forget what I said, what percent of the grade it is, but it's not a high percent of the grade. And if it, what? 20%, yeah. So it's not like a typical final. It would be a big percent of the grade. Uh, and if it looks like it's really useless, I might just not consider it. So, and so I'm sorry about having people come in just to do that. I just don't know what to do about, no one really knows what to do about this AI stuff. So that's what I thought of. Um, all right. Are there any questions about that? Okay, back to Kuhn. Okay. Uh, what is the function of the rest of this book after the first part? I mean, I kind of said before what I think it is, but um, I mean, the book is called Structure of Scientific Revolutions, but I'll just say one more time um, that I think the heart of the argument is the part about normal science. That's the really shocking part, the part about normal science. Um, and just to summarize again how normal science works, um, there's a paradigm, and paradigm is I mean, so a paradigm is kind of like it's a framework within which we work. So it's kind of like a, what a theory is for Popper. It's kind of like what a language is for Carnap. Um, it's uh, it's a framework we've adopted. We take it for granted. It can't itself be justified, at least not in the way that not in the same way as the things we're going to use this framework to assert, right? So just like for Carnap, a language, I mean, in a way, we can justify a choice of language because it's convenient for our ends or something like that. But it can't be justified as true or false. You can only start doing that once you have the language and you state things in it. And similarly for Popper, that the theory is not justified; it's a guess. Maybe we can give some explanations for why we guessed that, but we can't really back it up. So, um, so the same thing is true of Kuhn's paradigm, and in that sense, it's not that surprising that there's such a thing. And in fact, like Carnap's reaction to Kuhn was that, yeah, this isn't so surprising. Um, uh, and yet this framework determines uh, what counts as an observation at all, which observations are worth making, and what to expect as a result. So, like, um, the first of those is something that Carnap's language definitely does, determine what counts as an observation. The second two are more like what Popper's theories do, right? Like they tell us which observations to make. Remember, Popper says, like, sit someone down in a room and say, write everything you observe, and it's impossible. But once you have a theory, it tells you exactly what to check. And again, that's very much like what a paradigm does. Um, and a theory also, one of Popper's theories in a way tells you what to expect. That is, I mean, it tells you what to expect if the theory is true. And you guess that it's true. So it tells you what to guess. um, so, so the real difference between this and Popper is not that there is a structure like this. I mean, it's not exactly the same as one of Carnap's languages. I mean, again, it does tell you, it also gives you the vocabulary to talk about the world at all. Um, um, it's not so, but anyway, I think it's not that different for that, and it's not that different from what Popper calls a theory. But what's really different is the motive. Like, why do we have this framework? And again, I think you can see that difference most clearly when you compare it to Popper. And again, that's why Kuhn is in this part of the course. Like, according to Popper, the reason we want a theory that tells us what to do and what to expect is so we can test it, right? It tells us what to do and what to expect if the theory is true. So that is what to expect when we do that, if the theory is true, because that way we can try to show that the theory is false. Um, and if we use it that way, right? So here, maybe I should draw this like kind of side by side, right? Like, right? They both tell us what to do. and what to expect. We have the same thing here. But in this case, the reason it tells us that is so we can try to falsify it. And this is good because uh, as I explained it many times, right? Popper says we can't help but believing something, and beliefs are irrational. But if we form the right kind of belief, at least we won't get stuck with it, right? And the belief is one that tells us what to do and what to expect. That is, tells us how to test that very belief. Um, so even though there's this unavoidable irrational element to our theorizing, um, and you might say, right, remember, just as Kuhn says, there's like something arbitrary and idiosyncratic about scientific theories. Why we can't generate the theory just by a methodology. So Popper 100% agrees with that, right? We can't generate the theory by a methodology at all. It's all idiosyncratic, right? It's like there's a psychological explanation why we guess that theory rather than some other theory, but that's as far as it goes. But what's rational and free is the way we make sure that that irrational element is exposed to strict tests. Um, and so, right, this um, it makes us free and rational. I mean, or really free equals rational, right? This is a Kantian context, broadly speaking. Um, Being free means self-determining. That means like using reason to 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 determine your will. Um, so um, whereas here on the Kuhn side, the paradigm tells us what to do and what to expect. So so we won't ask the wrong questions. That is, it tells us that, oh, and my camera's pointed the wrong way. Um, it tells us, it reassures us that if we ask the right questions, um, they we definitely will be able to find an answer, and the answer will be in a certain range. So we know if we're on the right track or not, right? If the answer is not in that range, we know there's something wrong with our apparatus or something like that. Um, and it tells us not to ask questions where it steers us away from questions where we have no reason to expect that we'll be able to answer them. Right? Like, how can we achieve world peace? Is one of Kuhn's examples. That's a really important question. Like, if you chose your questions by how important the answer is, that would probably be near the top of the list. But what this paradigm does is allow us to reject questions, to not choose questions based on how much we want the answer, but rather to choose questions based on how likely it is we can answer them. And how do we know that we're likely to be able to answer them? Well, the paradigm, which we're taking for granted, tells us that. right? So basically, another way to put this is it tells us how not to test the parent, right? Because it tells us that um, here it tells us what to expect, meaning what to expect if this is right. Here it tells us what to expect, meaning we take for granted that this is right, and so we expect this, right? So it tells us that we're not taking a risk if we ask these questions. We know what kind of answer we're going to get. Um, and why do we want this? Not because it makes us free and rational, but because we're addicted to puzzle solving. And um, and as I suggested last time, there's more than a hint here that maybe Kuhn wouldn't advise us to keep doing this. Right? I mean, it doesn't sound very, it's not a great recommendation of something to say the motive for doing it is addiction. um, and I think, well, if you look at the if you look in more detail at what Kuhn contrasts with science, I think you might get even more strongly get that impression. So, like, because the question of the book is, why does science make progress in a way that, uh, and that is mature science, right? Which means especially physical science and also biological science. Um, so why does mature science make a kind of progress that other creative fields don't? That's like what that means exactly, I don't know, but it's like a piece of technical terminology for Kuhn, right? He keeps using it over and over. He says, compare science to other creative fields. Well, what other creative fields are there? So, um, one example is art. Um, right, this is on page 38. I don't remember if I got to reading this last time or not, but I'm going to read it anyway. Um, to solve a jigsaw puzzle is not, for example, merely, quote, to make a picture. Either a child or a contemporary artist could do that by scattering selected pieces as abstract shapes upon some neutral ground. The picture thus produced might be far better and would certainly be more original than the one from which the puzzle has been made. Right? So that we're comparing what the scientist does to solving the jigsaw puzzle. You get a box of pieces. There's a picture on the cover that shows you what it's supposed to look like. And if you can't make that picture out of it, you failed to solve the jigsaw puzzle. And even though there's no list of these rules on the back, and you might not even be able to list them yourself, you know what you're allowed to do when you're solving this puzzle and what you're not. Compare that. So we have a child or a contemporary artist. What are they going to do with the jigsaw puzzle? Well, they're gonna throw away the top and take out the pieces and say, ooh, look at these pretty shapes. How can I arrange them on a neutral ground? And Kuhn says that the picture they make might be far better. Um, and will certainly be more original. Um, so there's two things I want to connect that with. I guess, I mean, it might not be clear. I am getting back to the question I asked at the beginning, what's the rest of the book for? But I have to get back to it in a roundabout way. So, I mean, there's two things I want to connect that. First of all, is the um, Kuhn's discussion of art history. Now, we haven't got to this yet. It's on page 161. It's very short. um, I guess it starts on page 160. For many centuries, both in antiquity and again in early modern Europe, painting was regarded as the cumulative discipline. That might be a little bit of an exaggeration. The cumulative discipline? What about mathematics? I don't know. Anyway, during those years, the artist's goal was assumed to be representation. Critics and historians like Pliny and Vasari then recorded with veneration the series of inventions from foreshortening through chiaroscuro that made, however you pronounce that, that had made possible successively more perfect representations of nature. But those are also the years, particularly during the Renaissance, when little cleavage was felt between the sciences and the arts. Leonardo, blah, 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 blah. Okay. So Kuhn says that for centuries, painting was like this. It was, right? It was puzzle solving. The puzzle was like how to make the painting look more like the real world. Um, and uh, um, there were a series of advances in solving, I guess you could say, solving more and more difficult puzzles of that nature, or something like that. Um, so, I mean, first of all, this is interesting because it sounds like painting um, had, so to speak, crossed the threshold and become a normal science. Now, I don't know if Kuhn wants to go that far. I mean, it didn't resemble normal science in a lot of other ways. For one thing, it wasn't aimed, like paintings weren't aimed mainly at other professionals, right? They were aimed at a broad audience. Um, but anyway, like painting had some of the characteristics of normal science during those centuries. And then he says, um, only when the latter unequivocally, that is, the latter is painting, only when the latter unequivocally renounced representation as their goal and began to learn again from primitive models, did the cleavage we now take for granted assume anything like its present depth? That is, the cleavage between art and science. So, I mean, this, in context, is part of another point. He goes on to discuss technology there. It's one of the, there's not that many discussions of technology in the book. There's very few, actually. He kind of excuses that in the preface. He says, right, because this is supposed to be a mere essay in preparation for the big book that he's going to write, but he never wrote that big book. So this is what we have. So, but anyway, so in context, it's about something else, but it sounds like he's talking about this same thing, right? The contemporary artist, the child, and now we can also put in the primitive. the immature. So Ray, it sounds like the immature, well, he's saying the immature approach to the puzzle pieces might be far better and would certainly be more original than the mature approach to them. Um, um, and this is somehow connected to the imagination, I think. Now, exactly how, I don't know. I mean, obviously, like we don't have from Kuhn a whole like faculty psychology where he explains exactly what the imagination is and what it does. But he keeps referring to it. Uh, this is from the beginning of chapter 4 on page 35. Um, Sometimes as in a wavelength measurement, which again is what Kuhn himself was working on, I think, measuring the wavelengths of spectral lines. Everything but the most esoteric detail of the result is known in advance. And the typical latitude of expectation is only somewhat wider. Coulomb's measurements need not perhaps have fitted an inverse square law, blah, 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 blah. Yet even in cases like these, the range of anticipated and thus of assimilable results is always small compared with the range that imagination can conceive. Right, so the imagination can conceive. I mean, that's mixed, right? Is the imagination or is the understanding? Again, I don't like um Kuhn. I mean, Kuhn thinks it not only is kind of an outsider to the philosophical tradition, but thinks himself as an outsider and implicitly connects that to the fact that outsiders are often you know, they um, come up with new paradigms in science. Right. So, so like I think he doesn't feel responsible to necessarily use these technical terms in it. What am I saying? I mean, philosophers these days don't feel responsible for that either. Maybe I'm the only one who feels responsible. Kant certainly does, but I did, yeah, anyway. So anyway, be that as it may, imagination, whatever that is exactly, is what the child and the primitive and the contemporary artist are allowing free rein to, right? Whereas the scientist or the traditional artist are restricting themselves to a very small part of the range that imagination can conceive. Um, Now, the next thing I'm going to say is one of these like unjustified leaps that possibly is totally irrelevant here. Um, uh, there's an idea I got from this guy, Todd Gitlin. I'm not even sure who Todd Gitlin is, other than this one book I read by him about the movement in the 60s. and and he says there was the East Coast version that was like political and revolutionary, and there was the West Coast version that was expressive um, and like uh, imaginative, right? So like you know uh, kind of like contrast the Weather Underground with the Summer of Love or something like that. right? So, so like Putnam was part of that East Coast movement. It, uh, I mean, the timing isn't exactly right on either side. I don't think they, I mean, again, this book was published in 1962. So it's, I mean, yes, he was in Berkeley, but Berkeley wasn't that Berkeley yet in 1962. But um, but also another thing that Gitlin mentions in connection with the West Coast movement. And so this is something that was in France. So it's either on the West Coast or the East Coast. But people started writing graffiti in France in 1968. This, all power to the imagination. I guess this was in French, but this was a slogan of the Situationist International, which um, is some kind of really bizarre group of like anarchist, post-Marxist artists from the late 50s and the early 60s in Europe. This was one of their slogans, all power to the imagination. In 1968, that's what people were spray painting on the walls of Paris. Um, And here is something from the Wikipedia article on the Situationists. The Situationists possessed a strong anti-authoritarian current, commonly deriding the centralized bureaucracies of China and the Soviet Union in the same breath as capitalism. So, like, all power to the imagination means, instead of all power to the people, right? All power to the imagination means there isn't a political, like, revolution way out of this. That will just substitute another kind of um, authority that we're all subject to. The way out of it is through your imagination. Free your imagination. Take LSD, whatever. um, so now, I mean, I don't want to give the impression that Kuhn was at all like that, because as far as I can tell, he was not. um, and so, and yet, I mean, that is as far as I can tell, he was very conventional in the way he looked and, you know, dressed and acted and, etc. He wasn't like a hippie or something. I mean, there weren't hippies yet in 1962, I guess. But anyway, he wasn't one. And and he moved to the East Coast pretty soon. And, but I can't help seeing that there's a connection here. Kuhn is like doesn't think we can get out of this normal science thing by a revolution. Um, so, um, so now I'm back to the question, okay, so what does the book say about scientific revolutions and what's the point of talking about them? It's not to recommend that scientists have a revolution, right? So in other words, the way this term paradigm is used now most of the time, that is Kuhn's use of the use of it that's in Kuhn's footsteps nowadays is mostly like, we need a paradigm shift. Right? I'm going to tell you a paradigm shift that's gonna like Ray, it's gonna change everything. But um, um, but Kuhn um, is not recommending a paradigm shift. Well, he is and he isn't, and that's the confusing thing. But let me just focus for a second on what he's saying about science and not worry what he's saying about the history or philosophy of science. That is what he's saying about what he himself is doing. um, so um, because and this is what the rest of the book is for. The rest of the book is for showing that a revolution is not an even temporary escape from normal science. It's not a taste of freedom. I mean, because and and he has to show that because that's exactly what Popper will claim. So um this is this is I'm going to read now from Popper's response to Kuhn. So this is Kuhn contributed to that Schilp volume that Putnam also contributed to, and we didn't read that, but in Popper's response to it, he says, and this part of the response is not a response to something specific in what Kuhn wrote in that volume, but just a general response to Kuhn, right? So he says, I am prepared to admit now, following Kuhn, the existence of routines in science, and thus the existence of what he calls normal science. Right? So Popper is saying, I learned something from reading Kuhn. It's true that scientists sometimes get into this routine where they're not trying to test their theories. And they're just like going through certain experiments because they've been trained to that those are good experiments to do, whatever. That's what he's calling a routine. But then he goes on, but I think the very idea of a routine is uncharacteristic of science. And consequently, that normal science is not normal, but uncharacteristic. That is, that quote, normal science is not normal, but uncharacteristic. So, right, so first of all, Popper is saying, okay, I agree there is such a thing as normal science, but that's quote unquote normal science, but that's not science as I understand it. Science, as I understand it, is when scientists are not following a routine. Um, so, uh, so in other words, what a Popperian or what Popper himself might say at this point is something like, okay, it's true, we have these periods of normal science, but in between them, the part that you call a revolution is when this happens. Um, Popper actually says more than that. If I finish the quote, he says, I think that the phenomenon of a routine in science has become more prominent only recently, along with the mass production of scientists. And I think that Kuhn is projecting a comparatively recent phenomenon which he has personally experienced, not only upon earlier periods, but upon the whole long history of science. And actually, he goes on to speculate that it may be um, the need to train up a lot of engineers quickly for the modern arms race. This is what Popper says that has brought this routine science to right that made it necessary to train lots of. I mean, he's mixing engineers and scientists, which Kuhn would do, right? But um, it's made it necessary to train up, for example, a whole lot of physicists really quickly, so we can build better bombs. Um, when I was studying astrophysics, I was told that like a lot of um, um, kind of like coefficients that you need to calculate how radiation travels through a gas. So it's like really important for studying stellar structure and whatever. They were calculated by like bomb physicists. um, anyway, so um, uh, so Popper is saying uh, yeah, there is this thing, this routine that Kuhn is calling normal science. But number one, it's not, that's not where the real science is. And number two, it's normally very unusual. It's become usual now only because we're in a bad political situation. And so, I mean, it follows, although Popper doesn't say that there exactly, that explicitly, that if we want to get science back on track, what we need is a political change. Right? Then we could, I mean, that is within the politics of science, but Popper is saying, but it's connected to the broader politics, right? Like we need to end the arms race. So, um, uh, right. So the rest of the book, and I mean, again, like historically, this doesn't work out, right? That is, Popper is writing this a long time after this book was written. So it's not, right? It's the rest of the book isn't literally a response to what Popper wrote in that paragraph I just read, but it's a response, it's heading off that type of response. It's trying to say, um, it's focusing on revolutions in order to show you that that's not an exception. And again, that if there is a way out, it's going to be non-political. It's going to be personal. Right? Remember, Kuhn says, like, although the names of these men, by the way, I haven't mentioned this, that even though, I mean, I think all the people we read sometimes, well, most people who read wrote in German, where it's not exactly the same problem. But anyway, like there still is a problem. But uh, but even though all the people we read definitely didn't use inclusive language, right? Like they used male pronouns, whatever. For some reason in this book, it's like a drumbeat. It's like it's constant men, men, men. And there's one place I found this once, and I was kicking myself because now I forgot to write down where it is, and now I can't find it again. There's one place that's like a smoking gun where he calls the scientists men, and then um, when he talks about non-scientists, he calls them people. Right. So um, and why this is again in Berkeley in 1962, um, I mean, it might just be because of his writing style and the way people were told to write at that time. And I guess people are still told to write this way. Like try to make it vivid. Don't use abstract nouns like people. Use something more that gives you more of an image, like men. But that's exactly the problem with it, right? It gives you an image. The scientist is a man. But anyway, that's just a digression. I can't go into more about that now. But anyway, he says at some point, although the names of these men are not likely to be recorded by history, many scientists have probably left science in the face of anomalies, um, or just in the face of, I guess it says many people have probably actually left science because they were frustrated. Um, they uh, they took the theory to have been falsified by observations. I think that's the context. And he says that's the only response. Because if that's the only way you could respond to actually thinking the theory is falsified by observations. Because to remain a scientist, you have to not regard it that way. Right? So that right, like those men who left science, um, didn't they didn't lead a revolution to here's a new, better science, right? Where we're going to behave like Popper. That's impossible. It's like it's essential to science. It's what allows it to make this progress and to be professionalized in the way it is, that it's not like that. So all they could do was like personally check out. And remember, that's what Kuhn did. He found a way for his name to still be remembered by history, but um, that again connects to something that's a problem here, I think. So, um, okay, so that's all like setting up in probably much more detail than you wanted to hear. But I mean, setting up like what's at stake in the description of scientific crisis and revolution. Um, and now I'm gonna try to go into the details of it to see how that works out. I guess maybe I'll leave this stuff on here. All right. So there's so this part is back more to talking about the details of the text and like how to understand it, right? So um there two steps or maybe three steps. So one step is what's called extraordinary science. What? What's it called? Oh, I thought I misspelled extraordinary, but no, that's how you spell it. All right. And the second step is revolution or paradigm shift. Right. So there's definitely these two steps because even though it's sometimes confusing, but Kuhn addresses this explicitly. This is on page 90. Um, until section 6. I call them chapters, but he calls them sections because it's just an essay. It's not a book. So it has sections and not chapters. But anyway, until section 6, where the concept of anomaly was first introduced, the terms revolution and extraordinary science may have seemed equivalent. But now we can see they're not equivalent, right? So that's why I say these are two different steps. There's extraordinary science and there's revolution. There may be two sub-steps under here. So um, extraordinary science is not revolution because um, first of all, it might not even lead to a revolution, right? So extraordinary science um, um, takes place when a certain anomaly um, and an anomaly is um, any case where the theory, where the paradigm leads us to expect that a puzzle can be solved, but we can't solve it. um, we can't solve it using the means provided by the paradigm, right? That is, we can't solve it under the rules, or, but they're not just rules, but anyway, under the means, under the rules and subject to the other constraints of the paradigm, we can't solve it. But Kuhn says there's always lots of anomalies like that. The paradigms normally exist in a sea of anomalies. Lakatos also said that. Um, but normally they're just like um, considered to be really hard puzzles. And uh, we're still working on them, or they're too hard and we're not going to work on them. but maybe we'll come back to them later. Right? So, but extraordinary science begins when one of these anomalies somehow attracts everyone's attention. Um, but again, Kuhn says, um, extraordinary science can resolve itself. Now, he doesn't give any examples of this, but he says sometimes it happens. And it can resolve itself in one of two ways. Number one, we might actually figure out how to solve the puzzle. So then, in retrospect, it just was a really hard puzzle, right? And then normal science can resume. Now, again, I'm not sure exactly what that looks like because he doesn't give examples of when that happened. Um, um, the closest he comes, but I feel like he says that this was still normal science. So I don't know. The closest he comes when he talks about the precession, not of Mercury's orbit, but of the moon's orbit around the Earth, and how, like, for a long time, Newtonians were only able to account for half of it. And then someone figured out that there was a mistake in the math, and they were able to account for the whole thing, and so that problem was solved. The thing is, I feel like he says that anomaly didn't take over Newtonian celestial mechanics. So that's not really an example. I don't know what an example would be. But in any case, that certainly shows that this is not the same as revolution, because it can end, one way it can end is by it being resolved. And the other way it can end is by people giving up on that problem and saying, we'll shelve that for future research. Right? And then it returns to be one of the many anomalies that haven't been solved. And we can go on with normal science that way too. Um, so it's not a revolution. What does happen during extraordinary science? It's not just normal science, but it's not a revolution. A revolution involves, like, throwing out the old paradigm and starting in with a new one. So, but before that happens, we have this period of extraordinary science. And like I said, I think there are two distinct phases. Like, one is kind of the initial, I guess it's a normal fixation on the anomaly. Right. So we're still, like, treating it as a normal problem, but it's become a normal problem that somehow has taken over the whole field. And everyone feels like the future of the field can only continue if we solve this one problem. Um, so that's the first stage. And Kuhn says, why does this happen? And basically he says, could be a lot of reasons. He's not sure exactly why it happens, and he thinks there could be a lot of things that make it happen. Sometimes it's something external, like like people are demanding an answer to a certain question, because he mentions calendar reform, like people needed exact calculations of the orbits of the sun and the moon. Uh, but but it seems like other times it can be some kind of social or psychological forces internal to the field that makes this happen. But uh, so for a while, people do this. And then if the problem, even after everyone has focused their normal scientific methods on it, still resists solution, then there's this period of kind of like random groping. That's not Kuhn's term. I mean, one reason I'm not sure that there's these two different phases is Kuhn doesn't introduce terminology for these two different phases, right? So, like, I don't, maybe they kind of just, like, fade into each other or something. But it seems like this is really a different phase where so people um are still not questioning the old paradigm. They can't question the old paradigm and keep doing science. You can't do science without a paradigm. Um, right? Kuhn says that the very thing um, that once you accept his view of science, you'll see that this surprising fact that the old theory isn't rejected unless we have a new theory on hand, right? So remember, Putnam and Lakatos both emphasize that Kuhn says that surprising fact on his view of science will become a tautology. Of course, scientists can't abandon the old paradigm unless they have a new paradigm on hand, because if they don't have a paradigm, they're not scientists. So here in this phase, we still have the old paradigm. But what starts to happen is number one, that people become unclear about what the paradigm is. And number two, that they start um, uh, doing experiments just to see what will happen because they're not sure. They um, because they're not sure anymore what experiments the paradigm should lead you to expect will be valuable. Um, and he says this makes them very uncomfortable. It makes them uncomfortable in the way that, like, if you spend all your life solving jigsaw puzzles and you got a jigsaw puzzle and you keep trying and you keep trying and you can't make it work and you start to wonder, wait, what are you allowed to do as pieces? Can there be a curved part on the edge, or does that count as a jigsaw puzzle? And right. So, like, you're unhappy because you like solving jigsaw puzzles, not having unsolvable ones. Right. Um, so that's the first phase. And I think times. Yeah. So I'll come back and talk about that in more detail, but I want to then sketch out this later phase. So, so in this later phase, somehow Kuhn says sometimes it's usually one person, sometimes it's in the middle of the night. They just all of a sudden see a new way, pick up the other end of the stick, as he quotes someone saying, using that to describe scientific progress, right? They just like all of a sudden see a different way, a different set of rules that will allow us to, that will make this puzzle solvable. And will make it a fun puzzle and with a clever solution. um, it doesn't necessarily solve all the problems that the old paradigm could solve. It has to solve a lot of them, some of them, but um, but remember, everyone is, and like kind of irrationally, right? Like that's what that whole discussion of why does this happen, and well, it could be any number of reasons. Everyone is kind of irrationally fixated on this one puzzle. So if I can find a new set of rules that makes that puzzle solvable, people will be really happy, and they won't care that much if it like undermines the solution to some of the old puzzles. um, at least that's how some people react to it. Of course, other people will continue holding on to the old paradigm because they just don't understand how else to be a scientist. They never get the new paradigm. And eventually they become read out of science as cranks or whatever. Um, um, and at the end of that, the new paradigm is in place and everyone's back to normal science. um, I think there's some hint that in some places in the book that even here, like maybe there's the new paradigm has to battle against the old paradigm, and that there's some chance that the old paradigm will win. The new paradigm, even though it showed how to solve that puzzle, people won't accept it. But in any case, again, he gives no examples of that. So in the cases we're interested in where there actually was a scientific revolution, in the end, the old paradigm is gone and the new paradigm is taken over. Um, so Kuhn wants to show that even in these phases, he says this is the one actually where science looks the most like our traditional image of science, right? Because scientists are doing random experiments to see what will happen. Scientists are proposing um, they're supposed to be like articulations of the old paradigm, but they're like little um or also they may be like falsifying hypotheses, right? In the sense that they're like, okay, maybe this anomaly is the same as all these other anomalies. um so um so at some point here things look a little bit like what we meaning especially like what Popper would think that scientists are doing, looking for counter instances to their theories. um but Kuhn's overall claim will be um I listed a bunch of points here. Number one, science produces fundamental novelties inadvertently, right? This anomaly didn't come up because people were looking for an anomaly. It came up because they were looking for a problem with the usual type of solution, and it resisted it, which they didn't want. They wanted to solve the puzzle. So it was inadvertent. They stumbled across this. Um, Although Kuhn emphasizes that the fact that they're engaged in this activity of normal science makes it much more likely that they'll stumble across stuff like this, right? Because they're engaged in like making very precise measurements and solving very complicated problems that without their paradigm it would never occur to you to even try. But since they have the paradigm and they're able to take so much for granted, they're able to focus on these very esoteric things and they create very unusual circumstances. Um, and so these anomalies come out, right? So just think about like, um, I think you could watch Mercury rise and set, you know, for centuries and you would never notice that there, I mean, not that that wasn't the anomaly that caused general relativity. That was like later realized that general relativity could account for it. But I mean, but just think about that anomaly, right? Like you could observe Mercury with the naked eye, just like casually for centuries, and you would never notice that the precession of the major axis is so many degrees per year rather than so many, right? Like that number you would never even measure that number. You would probably never even realize that Mercury's orbit was an ellipse and then was around the sun and not the Earth, right? So, I mean, but in the context of Newtonian celestial mechanics as normal science, um, what you do is try to observe orbits really precisely, and then in order to extend the range and precision of the match between the paradigm and the world. And that's what allows the anomaly to emerge, but you weren't looking for it. It was inadvertent. So that's number one. We're not looking for anomalies. Number two, science responds to things that look like fundamental novelties by trying to make them go away. right? It's not just that, as Putnam and Lakatos both emphasized, and as Popper came back and said, "Well, I never said that." Right? It's not just that we don't let every fundamental novelty knock us off course and change our theory. It's that whenever something that looks like a fundamental novelty comes up, all the effort of science is concentrated on um, showing that it's not a fundamental novelty. um, and it will keep doing that until, well, until either the puzzle is solved, so it makes the novelty go away, or we give up on it. So, um, so we just irrationally put it back in the category of anomalies that we're ignoring. Uh, or someone comes up with a new set of rules. And if someone does come up with a new set of rules, um, and they win out, so we have a new paradigm now, science moves quickly to repress all memory of the old system. Um, so the new one can again be accepted without question, right? Because we need, again, we have to have this paradigm that's accepted without question, that everyone is trained um, to have this rigid belief in, because that's the only thing that makes the puzzle solving fun. Or I don't know if it's really fun. Like things that are addictive are not necessarily fun, right? Like maybe it's actually kind of annoying or oppressive, as Kuhn puts it, right? But still, I mean, it's what makes it addicting. That you're sure that there is a solution. If there was something kind of like jigsaw puzzles, but like uh no one had, like just cut out random pieces of cardboard and put pictures on them and like said, here, try to solve this. And you had no reason to think that there was a solution. Like no one would buy those puzzles. Right. So um uh or as Kuhn sums it up, this is on page 52. That is what fundamental novelties of fact and theory do. Produced inadvertently by a game played under one set of rules, their assimilation requires the elaboration of another set. And assimilation means, I mean, again, I wonder about some of his metaphors. I actually talked to ChatGPT about articulation, and it gave me a pretty good answer. And it even like quoted Plato and stuff. But about carving nature at the joints. So articulation means giving the paradigm more joints to carve nature at. I don't know if that's, but anyway, assimilation, like assimilation is what happens when you digest food, right? Like the food starts off as something really different from you. And by the time you're done digesting, the food is you. So it's been assimilated to you, right? Um, So I'm not sure exactly what the metaphor here is, but I think that assimilation means like um, making it available for puzzle solving. Um, boy, I'm really low in power now. 7%. Oh, I see Josephine is on the Zoom. I didn't notice that. Josephine knows more, has come up with some more situationist international slogans, like it is forbidden to forbid. And was it real Plato? I didn't, I mean, it was something that Plato really said. I didn't check to see if it gave me the right Stephanus number though. But anyway, but that phrase "carving nature at the joints" is, or yeah, that is from somewhere in Plato, I think. Um, all right. So the question is, oh, right. So the reading for this time is basically about this. Right. So now I've introduced the whole second part of the book, but the reading for this time, chapter 6 through 8, was basically about this. Whereas the next reading is going to be about this. So, and the challenge in this part um, is to show that nothing that happens in this is like the falsification of a theory. Okay, I think I already addressed some of the things I said here, but right. So let me actually skip some of the general things I was to say about that and go into more detail. So so Kuhn divides. So right, this phase is all about the anomaly and how we respond to the anomaly. And Kuhn then divides it. This is the difference between chapter 6 and chapter 7. Wait, which is which? Yeah, it's the difference between chapter 6 on the one hand and chapter 7 and 8 on the other hand. Divides this into um into like observational anomalies and theoretical anomalies. Or into anomalies that will lead to, after the revolution, will lead to discoveries versus ones that will lead to inventions. This is his terminology. Um, right. So an example of this that he discusses at length is the discovery of X-rays, where the initial anomaly, and this is something that happened within a single laboratory at a, over the course of a couple months or something. So it's not a huge, large scale scientific revolution, but Kuhn says it has the exact same structure. So even at the smallest level, in the most specialized field, in something that maybe like outside of that field wouldn't seem like such a big deal, we see the same process. So the anomaly is that a detector that is like um, outside the apparatus and is not supposed to be part of the experiment at all suddenly starts glowing. um, and Röntgen is like, hey, what's that? That's the anomaly. Um, uh, Whereas these that Kuhn treats at greater length in chapters 7 and 8 are ones that lead to the invention of new theories. Um, right. So I think the one he discusses at the greatest length is the chemical revolution. I mean, he discusses that actually both here and here, because he discusses it here. He discusses the discovery of oxygen. But in this one, he discusses the invention of the oxygen theory of combustion. And as you can see from that example, and as he points out from that example, these things are not as distinct as you might imagine. right? Like, because the paradigm, it's not just a theory, it's a theory plus standard instruments, standard testing techniques, um, uh, um, expectations about what kind of things generally are in the world. Um, so, so if there's a mismatch, it typically is gonna, to some extent, implicate like both of these things. Um, but so I guess one question would be, why does he make a big deal about separating them if he thinks that in the end they're not that distinct? I think maybe it's really actually to show you in the end that they're not that distinct. Um, so so in the case of these discoveries, it's like we observed something, we see something that we didn't expect. Um, and under the right circumstances, which again, you can't explain exactly what the right circumstances are, right? Like he says, in the case of the discovery of X-rays, other people had also seen that spot and didn't really, were like, oh, I wonder why there's a spot, and just went back, right? That glowing spot on the screen. Other people had already seen it, but they didn't fixate on it. But Roentgen did. Why? We don't know. Right? So, but we see something we didn't expect, and we fixate on it. Like we like, wait, what's going on? um, um, and uh, the paradigm didn't prepare us for that, but it's only because of the paradigm that we were able to observe it. Um, so like similarly, and this is right, Kuhn on page 62 through 64 describes this series, this experiment that that he thinks is a metaphor, maybe even on some level like an example of this kind of revolution, right? And so the experiment is that's the experiment where they show people cards, and they show them cards really for a really short period of time at first, and they try to identify what card they've seen. And then they show it for longer and longer periods of time until they can identify it. Um, and many of the cards are normal cards. And with the normal cards, at the very short exposures, they can't say what it is. But as the exposure gets longer, they get more and more confident what it is, and they're usually right. So, but they also mix in these cards like uh, red six of spades, or maybe it was a black six of hearts, or anyway, something like that. What? Black four of hearts, right? Whatever. I mean, okay, so there's a black four of hearts. So it looks like a four of hearts, but instead of having red hearts, it has black hearts. And with that, um, uh, again, at the very short exposures, at first they can't identify it at all. When the exposure gets longer, they identify it confidently as either a four of hearts or a four of spades. And then when the exposure gets even longer, they start saying, I don't know what that is. It looks like a four of hearts, but there's something wrong with it. There's a black border around the hearts or something like that. And then an even longer exposure, most people eventually are like, oh, oh, I see what it is. It's a black four of hearts. How weird. Right? That's the revolution. Now they're able to see what they couldn't see before. But um, but it started with them seeing something anomalous. And that paved the way for them acquiring a new way of seeing cards. But then some people, Kuhn says in this experiment, some people never saw it. Like no matter how long you showed them the card, they just couldn't figure out what it was. And they started and they became extremely distressed. They're like, I don't know what the devil is going on. Right. So, but you see, like, so that experiment is supposed to be a metaphor for this. You know, we were looking at the same thing the whole time, but at first we just saw something normal, but then we saw an anomaly. And then we got upset by the anomaly because we couldn't figure out what we were looking at. And then all of a sudden, a flip. Um, right? Which Kuhn also connects to the idea of a Gestalt switch, right? Like when you suddenly, um, when you see a duck, you see a duck, you see a duck, and then suddenly you see the rabbit.